Hi there, welcome back. Today we've got something completely different again. This seems to be the rule on this channel rather than the exception. This is a North Star Design Model 192 DAC. And the problem with this guy is that it is blowing fuses. Just a quick look at the front here. We've got the input selection, 4 selects. There's the lock light, selection of the frequency you want the sampling to be done at, and there's also an upsampling option. There is nary a scratch on here. This thing is beautiful. Having a look at the back, we've got our digital inputs here, input 1, 2, 3, and 4. As you can see, you've got 2 RCA inputs, you've got a XLR. There's a, what is that? Input 4 seems to be an Ethernet connection. Analog outputs, right and left. And then, of course, just the power switch with a built-in fuse. Now, the problem is that fuse is blowing. Now, it's a 315 milliamp fuse, so it's a pretty small amount of current, but it's blowing. Now, what I know about this is it's because the switch, the on-off switch, is at the back, and there is no switch on the front. This thing has been left on for years and years and years. Now, I don't know exactly how many years the owner's had it for. He ended up trading it with a friend of mine. So this is now my buddy's, and he's a great buddy because he lets me play with these things. Now, that could be ominous. Now, the problem with these pieces of equipment that are left on day in, day out, week in, week out, literally year in, year out, because there's no on-off switch at the front, and he didn't have this thing connected to a switched amplifier, for example, is that it does go into a little bit of stress after a while. Now, the opinions on that vary, but if we just look at the simple case of the capacitors, all filter capacitors, no matter how good they are, have a certain number of hours attributed to them. And if you think about a year, what is a year? It's a lot of hours. Now, do that for 5 years, 10 years, and sooner or later, even the best capacitors are going to finally kick the bucket. So I have no idea what it is. I have no schematic, but I think it might have something to do with just the power supply. But we'll open it up and see if something's obvious. Okay, so 7 or 8 screws later, we've got the top off. I did it very carefully because the screws, even the screws, seem to have never been removed. Absolutely no tarnish, no scratch on them. And here we have it. This is quite a beast. There's some relays over here. This, I would imagine, is a supply rail set of ICs. This could be voltage regulators. I have to look closely at that. This is connected to the analog inputs, analog outputs, I beg your pardon. That would seem to be the supply ICs, voltage regulators. Quite a few of these caps. I don't actually see any bulging capacitors. I wish I did actually, because that makes it easy. I don't have a schematic for this, so when you see something obvious, it's a great help. It's got 2 transformers, 2 toroidals, very good quality, and it's got a line filter in here coming from the line in. This is 240 volt mains over here, and I think I'm just going to have to, because it's actually shorting, or it's actually blowing fuses, I'm going to concentrate on the obvious, which would be the power supply. See if there's anything obviously shorted. There's another set of supplies over there. These are the bridge rectifiers. 3 small ones, and again, more capacitors. Is that a bulge? No, unfortunately not. It's an optical illusion. So here we have another set of diodes down there. This thing is full of voltage full of supply lines. So you got 1, 2, 3 voltage, 3 bridge rectifiers over there. There's another 4 diodes. That seems to be another bridge rectifier. And I think we probably have something here as well. No, this is just voltage regulators. So if it is a supply issue, there's certainly a lot of places where it could have gone wrong. Any one of those ICs could have blown, and that would create a short. So time for me to start checking components there, and I'll report back if and when I find something. Okay, so first things first. I've put in a new fuse, and it's a 315 milliamp fuse. I'm leaving it as standard. I've connected the isolation transformer and dim bulb limiter to it. I've got this on maximum limit, so this is the only light that's on. Those are off. They are now. It's on limit. It's off. I'm going to switch it on. And now I'm going to power up the unit. And look what happens. Boom. Very bright. It's drawing about 300 milliamps, and it's actually providing only 50 volts. 50 volts AC to the unit. In other words, this thing is definitely got a problem. So, what are we going to do? It's not doing any damage. It's only drawing 300 milliamps, which means that if the transformers are working, the boards are seeing very little voltage. One of them is probably being dragged down to 0, which is the short. If I put in another one, just for luck, goes to 360. I don't want to blow the fuse. And it's still very, very much shorted somewhere. So let me show you something. The two transformers are independent, as you can see. And one of them says 909 at the bottom there. And the other one says 18018 on the top there. Now, the first thing I want to do is find out, A, if the transformers are okay. It could be a short in the transformers, I hope not. And the way to do that is to remove those, but I'm going to remove one at a time. I think I'll remove the 18 volt one first. And the reason I want to do that is because these two supplies are independent, it seems. And it makes sense on a DAC. On a DAC, you've got a hell of a lot of digital going on, and then you've got supplies that can carry noise back to other parts of the circuit. So it's not unusual to have independent supplies, one for the analog circuitry and the other one for the digital circuitry. And the probability is that, I say probability, I have no certainty about this, but the probability is that it's only one of the circuits, and I want to find out which, whether it's the lower one or the upper one. So I'm going to remove one of the transformers and see what we get. So I've desoldered that transformer there, the secondaries. I've wrapped them up so we don't get any shorts. And we're going to try it on again. So let's see what happens now. Here we go. Okay. Oh, we've got exactly the same problem. All right, I'll desolder the other transformer, see if we get any difference. Okay, so now I have desoldered the second transformer secondary from the board, and I've got it on here, full limit. Whoa. Oh dear, the problem is in the transformer. It could also be in the filter. It could well just be the filter, but I doubt it. Looks like our transformer's got a problem. Just feeling it for heat, and I think one of these is actually warmer than the others. Yep. Yeah. The first transformer is actually warmer than the others. Let's have a check. Ambient temperature, about 25 degrees. We do live in paradise. Let's have a look. 33, 34 degrees on that transformer. This one, 26. That guy's got a problem. It's slightly warm. Okay, so we've got a blown, what is it, 18 volts transformer. What a shame. What a shame. All right, I'm starting to smell something now. I better put this off. So at least we know where the problem is. And if that is all that's wrong with it, which I doubt, usually what causes that thing to blow is excessive current draw through here, and the fuse might have been wrong. You know, people tend to just replace fuses with whatever they find, whatever's on hand. If that's been the case, we've got a problem, because the problem would be there. But the way to figure that out is to find another 18018 connected on there. I'll have to remove it from there because that's obviously creating a short on the primary. Bloody hell. And see what happens. At least I know where to go now. Okay, so I removed the transformer completely, and I've connected the other one to the circuit. Now let's see what we've got. Okay, I'm going to switch it on now. Okay, I heard some clicking. Okay, so the 909 is working, and something else we can see. Something is on here. Some of these lights are on. The relays are clicking. This is the input select. 1, 2, 3, 4. There's the lock. So the digital circuitry seems to be working, and we now know we've got a problem with the transformer. What we don't know is if the problem is only with the transformer or if there's something wrong with the circuitry that it feeds, because usually that's what causes a transformer to burn out, is excessive current draw. But it may not be. It may not be. I've seen cases before where just the primary burns out, which is the case, seems to be the case here, and it was not caused by excessive current draw on the secondary. So what I'm going to do is actually I'm going to experiment with an alternative transformer to see if I can't get this thing to work, and then I'll know exactly that, I'll know exactly what I need to repair. The transformer in question is actually made by North Star, probably rebranding. Primary 0 to 115, 50 to 60 Hertz. So this is obviously, they've obviously put these in series because we work on 230, and then we've got the first secondary says 14.5 volts at 6.3 or 0.63 amps. So 630 milliamps. And the other one is the same, which means 0.15, 0.15. So we need a 230 volt primary, or 2 by 115 volt primary, and 2 by 15 volt independent, at least that's what they have here, independent secondaries, providing about 0.6 amps each. Can we find something to test that with? Well, as it happens, yes we can. We've got this guy, 2 by 115 primaries, 2 by 15 volt secondaries at 15 VA, so that means 1 amp each. So this thing is slightly higher rated than the transformer we've got, but it'll be good enough to test with. So I'm going to wire this in and see if we can't get the whole thing to work, and then we know that the only thing wrong is the transformer. Let's keep our fingers crossed. So here we are, we've got everything wired up. I've wired up the mains supply, the 230, to the same switch connection as it was before. So it's coming along here. The short in the middle is to join the 215 volt primaries in series for 230 volts. Over here we've got 0.15 and 0.15, the two AC outlets completely independent. They're going here exactly the same as it was before. And I think it's time we switch it on. So what's the worst that can happen? Well, it could actually show us the same short or a similar short, and I'll switch it off fast enough for this transformer not to heat up. But if it's working, we should see nothing. Nothing really. So I've got the same situation, put that on, and now I can switch this on. Brilliant. Ha! Okay, it's drawing 50 milliamps. Let's reduce the limit. There's hardly any limit because there's such a small current coming through there. The device is seeing 227, 228 volts AC, drawing 50 milliamps. I've got those same LEDs on, you know, the input selector and the lock. And everything's looking good. I don't know if it's working yet. I need to test it. And why do I do this? Well, as I've said countless times, I live on the island of Madeira. We can't just go around the corner and buy components easily. We've got to order them, and it takes a while to get here. And so I like to make sure that I don't need anything else when I place an order for a transformer. And I can get it. We have RS Components supplying to Madeira. Pretty fast, actually. And they charge, I think it's €5 if you buy less than 50 euros. If you buy more than 50 euros, you get free shipping. Now that's pretty good when you live on an island like this, because otherwise you literally have to wait for weeks, and that is not fun. So next step, put this together and actually test it. See, I'm going to find an input here, probably from my Mac, and see if we get an output and see if this whole thing's working. If it is, then I know that all I need to do is order a transformer like this one, and I know I can get them very similar to this, toroidals. This thing is, as I said, 630 milliamps at 15 volts, or 14.5, same difference. So we're talking about 10 VA per secondary. So you're looking at about a 20 VA toroidal transformer, dual secondaries of 15 volts, and a 230 or a 2x115 volts primary. And it's got to be big enough or the right size to fit in here, which is about 32 millimeters high. All right, here we go. The moment of truth. I've got this thing precariously set up here. The transformer is sitting there very carefully, so it doesn't touch anything that it shouldn't. The power is connected. I've got the output connected to, through the suites, this is Christmas after all, to the input of that B&O. I have the input here, input 1 is a Toslink connector to my Apple TV. And this whole thing is going to be playing through my Mark Audio full range speakers. There's the right one, and the other one is obviously, guessed it, on the left. So now I'm going to hit play.
A naked amplifier to do some repairs on, and I didn't strip it. The owner brought it in.
There we go.
I believe he tried to do some repairs on it, and the result.
Watching myself on YouTube. Jesus, that's got to be some kind of ego deficiency there. The point is, this thing's working. I can change the input select. Actually, what you're listening to there is just the TV, but that's the TV, and now when I put it on 1,
at the back what you've got is the 2 inputs, the speaker outputs.
There we go.
Light. There's a fuse. They've got the power transformer.
Okay, I've actually switched off the speakers on the TV itself, so you can hear that it is from here. Input 2, nothing. Input 3, nothing. Input 4, nothing. Input 5, not 5. What is it? I want 1.
Board at the back
there we go.
And,
shows the lock.
Look on further, a lot of.
And I've got 192 upsampling. I can take that off.
Your right channel tied to the right heatsink.
So
you see there.
It seems to be working, and it seems to be just a faulty transformer. I'll say just. It's not exactly the cheapest part of the device, but this is a pretty expensive DAC. So spending 30 euros or something on a transformer is not going to break the bank. And my buddy's going to be very happy, I'm sure. So I'm going to close this up now, order the transformer, and just put it in and give it back to him. And that's about it. I'm not going to show the whole waiting for the transformer bit and soldering it in because that's pretty boring. But you get the picture. Well, there is another one. Thanks for watching, and see you back soon. If you liked it, please click like, subscribe, and all that jazz. And if you want to support the channel, you can do so on Patreon. Thanks for watching. Bye for now.